Today we're going to look at how to determine significant figures and do calculations using them. You should have a half sheet of paper with a notes guide that you simply need to complete and add examples to. When we measure in science, we follow one basic rule for measuring, and following this rule allows scientists to determine exactly how precise the tool or instrument was that was used to measure the item or object. So, when measuring, you always record the number of digits that can be directly measured with the equipment plus one extra digit that you estimate. If you do that, you've measured using the rules of significant figures. Let's look at ruler A up here on the top. I'm sure this brings back fond memories of TCAP in grade school and the rulers that you used to use. And if I'm trying to measure this brown bar, I know that the brown bar is 4 centimeters long. And now I need to estimate how far it is between my 4 and 5 centimeter marks. So some people might say 4.5, some people might say 4.6, some people might even say 4.7. And so my estimated value is the tenths place. I know it's 4 centimeters, that's my known value, and then I estimated one place past that. 4.5, 4.6, 4.7. We can all differ a little bit on our estimated value. If I look at ruler B down here at the bottom, I have my same brown bar, but now my ruler has more graduations on it. It not only shows centimeters, it also shows millimeters. So now I know that the brown bar is between 4.5 and 4.6 centimeters. So now I can say it's 4.55 centimeters or 4.56 centimeters. And my estimated value is now the hundredth place because my ruler got more precise. If I'm using digital equipment, I simply need to record the exact value that appears on the screen. There are two rules for determining significant figures with recorded data. Rule number one is that you box all non-zero numbers and any zeros that are in between them. And rule number two is that you box all zeros to the right of a box where there is a decimal place. Let's look at some application of those two rules as we practice this. So I have 4 different measurements, and each one has differing significant figures based on the application of these ideas. I have 200 up here, and following rule number 1, I would box this 2, but I would not box any zeros to the right of it because there's no decimal place. So one significant figure, and what that tells me is that they estimated to the hundredth place. Not very good quality data. If I have 200 with a decimal point recorded, then I end up with 3 significant figures. Because following rule number 1, I can box the 2, and following rule number 2, I can box all zeros to the right of a box where there is a decimal place. So that would take care of these other 2 zeros. This means that they estimated to the ones place. So we know with certainty the 200 and the tens place are correct, and it's the ones place that's the estimate. My next measurement is 200.0. And for this I have 4 significant figures because as stated earlier with rule number 1, I can box the 2. And with rule number 2, I'm able to box all 3 zeros because they're to the right of the box since there's a decimal place. This means that my data is estimated at the tenths place. The instrument that I'm using is getting better and better. Now look at 0.002. It only has one significant figure. And that's because if I follow rule number 1, I can box the 2, but rule number 2 says I can only box zeros that are to the right of a box. And these zeros are to the left. Why in the world do the zeros on the left not count? Let's explore that. Imagine the following scenario. I measure the mass of an object to be 2.3 grams. That has 2 significant figures. My teacher's been bugging me about the quality of my data, and as a result, I convert the grams to kilograms. 2.3 grams becomes 0.0023 kilograms. That would be 5 Sig Figs if I count all the zeros. I should totally convert my data every time, right? Then my teacher's going to be like, wow, you have the best data. Did converting between units improve the quality of my data or the precision of the tool I used to measure it? No! Thus, zeros to the left of non-zero digits cannot be significant. 0.0023 grams only has 2 significant figures. Let's practice using significant figures. For our top value, 25.31, how many significant figures are there? Hopefully you said 4, because we're just following rule number 1 with this one. We can box all numbers that are not 0. For number 2, I have 100.0. How many sig figs would that have? Again, you should have said 4, because I can box the 1, and all 3 of these zeros will count based on rule number 2, since they're to the right of a box and there's a decimal point. Okay, now I have 0.0634. How many sig figs would that have? Well, if I look at that, it's going to only have 3 significant figures, the 6, 3, and 4, because the zeros that are to the left of the box, as we just discussed, don't count. Now let's look at our last problem, 205. How many significant figures would that have? Well, for that one, we only need rule number 1. I can box all non-zero numbers and any zeros that are between them. So this would have 3 significant figures. Okay, when we go to calculate with significant figures, our calculations as we multiply and divide, we have to record our answer using the same thought process related to significant figures, because we don't want a recorded answer after calculations to imply that we had better precision and tools than we really did. So for multiplication and division, we need to give as many significant figures in the answer as there were in the measurement with the least number of significant figures. So we can see an example of that. I have 2.568 times 5.8 divided by 4.186. And when I put that into my calculator, I get this big number appearing on the screen. And let's be real, how many of you have asked, where should I stop recording? Sig Figs tells us that answer. So if I consider my rule, I want my answer to have the same number of significant figures as the measurement that had the least number. Well, this measurement has 4, this one has 2, and this one has 4. So I need my answer to have 2 Sig Figs. I'm going to round, and so to round to 2 Sig Figs, I'm going to get an answer of 3.6. Okay, addition and subtraction, very similar. I'm going to give the same number of decimal places in the answer as there are in the measurement with the least number of decimal places. So if I look at my measurements, this one goes to the hundredths place, the thousandths place, and so my answer, as shown on the calculator, goes to the thousandths place, but following the proper rules of significant figures, I need to make that into the hundredths place. That would be 5.01 after I round. All right, let's try 2 problems and see how you're doing on this. 2.05 times 0.082. When I put that into my calculator, I get 0.1681. Should I just write that number down? Well, let's go back and look at multiplication and division with significant figures. It said that I can only have the same number of significant figures in my answer as I do in the measurement that had the least amount of sig figs. So This measurement has 3 sig figs because the 0 is between 2. We can follow rule number 1 there. This measurement only has 2 significant figures because both of these zeros are to the left of that box. So my answer needs to have 2 significant figures. That means I'm going to round it, and I'm going to round it to 0.17. Again, this 0 wouldn't count as a significant figure because it's to the left of the box. All right, let's try with addition. 0.255 plus 10.25. So if I look at that, addition tells me I need to look at the decimal place values in my answers and record my answer to the least number of decimal places from my measurements. So this first measurement goes to the thousands place, and the second to the hundreds place. That means that my answer needs to go to the hundreds place. So 10.505 becomes 10.51 when I round it to the hundreds place. Please complete the questions that you see on the Schoology assignment to practice applying the rules of significant figures. You may submit the assignment multiple times if you need to.